2.1.4 Covalent bonding. Remember, when atoms share a pair of electrons, they form a covalent bond. Now, if they share one electron each, that's a single covalent bond. But remember, with alkenes, if they share a pair of electrons each, that becomes a double bond. Many small molecules, maybe simple covalent molecules, contain covalent bonds. And there's 8 you need to remember. There's some that are atoms, so like hydrogen, oxygen, nitrogen, fluorine, chlorine. They are simple diatomic molecules where you've got H2, O2, Cl2, F2, N2. Simple diatomic molecules. Then you've got some where hydrogen is bonded to another substance. So for instance, hydrogen and chlorine bonded together makes hydrogen chloride, HCl. Hydrogen and oxygen bonded together makes water, H2O. Hydrogen and nitrogen bonded together makes ammonia, NH3. And hydrogen and carbon bonded together makes CH4, methane. The other one to consider is CO2, carbon dioxide, where the carbon has a double bond with each oxygen. Make sure you know these before you move on. Some covalent bonding substances are larger as well. Remember when you did about alkanes, you did about hydrocarbons being a mixture of alkanes. Some of them are short chain and some of them are long chain alkanes, but they all contain atoms that share a pair of electrons. They are covalently bonded. Remember, if you take an alkene and you join it together with repeating units of alkenes, you take a monomer and you make a polymer. Polymers can be really large molecules, and when they join together, remember they're bonded by covalent bonds. Our representation of simple covalent molecules or giant covalent molecules are limited, and there's 3 limitations that you need to know. Firstly, they're often drawn not in the correct shape. If you're going to do A-level, you'll realise about the bond angles that are required, but even those aren't perfect. The other one is we often leave gaps where maybe there aren't spaces between the atoms. And thirdly, we often draw them 2-dimensional when our drawings actually should be 3-dimensional. So we've talked about simple covalent molecules. There are also giant covalent molecules where many atoms, non-metal atoms, join together. 2 that you must know about are diamond. Diamond contains carbon atoms, and each carbon atom has 4 covalent bonds, and it forms a giant structure. The other one just like it is silicon dioxide, where each silicon atom joins with 2 oxygen atoms all together, and it forms a giant structure. Make sure you see some pictures of these, and make sure you can just see how the drawing that we do doesn't represent the giant structure of these compounds.